Hello, I'm Ali Al-Maweri and I'll be talking about the state design pattern. This is really useful pattern when dealing with objects that need to change behavior dynamically based on their stats. Introduction. Today we will cover what the state pattern is, why and when we should use it, how it works, breaking down its structure, the benefits and drawbacks of using it, some real-world examples where this pattern is applied, and finally, I will walk you through a code demo to see it in action. By the end, you will have a clear understanding of this pattern and when to apply it to your own projects. Overview of the state pattern. The state pattern allows objects to change behavior dynamically without needing long if-else chains or switch statements. Instead of messing our code with conditionals, we spread behavior into different state classes. Intent of the state pattern. The main idea behind this pattern is simple. An object should change its behavior when its internal state changes. From the outside, it may look like the object is changing class, but in reality, it is just switching its internal states. Instead of hard-coding behavior in a single class, we delegate behavior to state objects, making things clearer and easier to manage. Motivation behind the pattern. Let's take an example. Imagine a traffic light system. It has three stats: red, yellow, and green. Red means stop, yellow slow down, and green go. Without the state pattern, we might handle this using a massive switch case statement or if-else condition. But that isn't hard to maintain. With the state pattern, we create separate red, green, yellow state classes, making transition between them smooth and organized. Structure of the state pattern. First, we have the context. Then we have the state interface, concern stats, and state transitions. Think of this like a game character that can be running or jumping. This character is the context, changing state, and each state controls the behavior. The context. This is the main object that holds the current stat and delegates behavior. Then we have the state interface. It defines what all states should do. Then we have the concert states. Each state has its own class with specific behavior. Then we have the state. Then we have the state transitions. The context decides when to switch stats. UML diagram. Here's a visual representative of how this works. The context maintains a reference to the current state. The state interfaces the method handle. Each concerned stats like red, green, or yellow implements the handle method differently. This design keeps our logic model and easy to extend. Concert states and traditions. The set statement method is handled by the context class. Let's go back to our traffic light example, where red means that the car must stop, and yellow means that the cars should slow down, and green means that cars should go. So each of this behavior is handled by its own state class, and the traffic light context simply switches states instead of using messy conditions. Why should we use the state pattern? Each state is a separate class, making the code more readable. Eliminates long if, else, or switch statements. Adding new statement is easy without breaking external code. Disadvantages of the state pattern. Of course, nothing is perfect. Each state requires its own class, which increases complexity. If you have just 2 or 3 states, this pattern might be unnecessary. It is great for complex state-dependent behavior, but too much for simple cases. Consequences of using the state pattern. Overall, using this pattern gives us flexibility. We can modify or add states without breaking other code. Clear code reduces messy conditions and keeps behavior summarized. Easier maintained. We can tweak a state behavior without affecting the rest of the system. When to use the state pattern. Use this pattern when an object changes behavior depending on its state. You need to avoid large if-else conditions. The system has multiple well-defined states with distinct behaviors. It is not necessary for simple state managements, but it is great for complex conditions. Real-world examples. This pattern is widely used in real-world applications. Some examples would be vending machines, document workflow, and media player. Vending machines state like ideal, accepting money, dispensing products. Document workflow states like draft, review published. Game development states like playing, pause, game over. Traffic light switching between red, yellow, and green states. Even media player follow this pattern. Think, playing, pause, stop. Now let's take a look at demonstration of the state design pattern in action. The example we'll be running represents a traffic light system where the light changes states dynamical between red, green, and yellow. This is perfect use case for the state pattern because each traffic light state has distinct behavior, and we want to avoid complex conditions structure like a huge if-else or switch case block. State interface. In our implementations, we start by defining a state interface called traffic light state. This interface has a single pair virtual function handle, which is implemented by each state. This ensures that every state follows the same contract. The traffic light context class acts as the context that maintains a reference to the current state and delegates behavior to the state. It has a function setState that allows transitioning between states, and changeLight, which calls the current state's handle method. Then we have 3 concert state classes: red state, green state, and yellow state. Each class provides its own implementations of handle, printing the corresponding traffic light behavior. The green state and yellow state follow the same structure but with different output. Before we run the code and see how it behaves, we first create intents of red, green, and yellow states using make_shared. Then we initialize our traffic light context with red state and call changeLight. This prints traffic light in red.stop. Next, we use setState to switch. Next, we use the setState to switch to green state and call changeLight again. The output changes to traffic light is green, go. Finally, we transition to yellow state and print traffic light is yellow, slow down. Now let's run it. and see the output. As we expect, we see. Okay. As we expected, we see traffic light is red, stop. Traffic light is green, go. Traffic light is yellow, slow down. This demo highlights how the state pattern enables dynamic behavior changes in an object without relying on conditions. In terms of checking the state manual, the object delegates behavior to the current state. This makes the code more maintainable, scalable, and easy to modify. If we want to add a new traffic light state, like blinking red or blinking yellow, we simply create a new class implementing traffic light state without modifying the existing logic. Conclusion: the state pattern helps manage changes in an object's behavior based on its stats. It keeps status-specific rules separated, making the code easier to understand and update. This is useful for things like traffic light, vending machines, or games, where objects go through different states. References. Here are some references that I used. Thank you.